Thanks for everyone for joining us tonight, or this morning, or this afternoon, I guess, depending on where you are, on this session about local debugging, development, and how to accelerate your development and test loop using LocalStack, and how you can still integrate LocalStack with Lumigo to help you get that observability into what's happening, so that you have one set of a tool chain all the way from local development to running in production. And so, as a quick way of introduction, my name is Yan Cui. I'm an AWS Serverless Hero and a development advocate at the Lumigo. And today I'm joined by Waldemar, who is the founder and the CTO of LocalStack. Hey, Waldemar, do you want to say a few words about yourself?
Yeah, thanks so much for the intro. It's great to be here. Thanks so much for to Lumigo for hosting this webinar. It's a pleasure to share some deep dives on LocalStack here today, and especially also how it plays together with Lumigo. So very much looking forward to our conversation here, Jan.
Yeah, so for those of you who haven't seen Lumigo before, Lumigo is, in my opinion, the best observability platform for serverless workloads for sure, but it also supports the containers and existing microservices architecture as well. With Lumigo, you can trace your application even when it's going through lots of different hubs, going through your containers, as well as your Lambda functions and event bridge, and then Lambda function again, and then DB streams, Lambda functions, and some more. Even when you got this really complicated event-driven environment, you can see everything in one go using the built-in distributed tracing capabilities that just works out of the box. You don't have to add any code. You don't have to change any of your application code. It's basically one click, and you get the full observability into everything that's happening in your environment. And as I said before, it works across both containers as well as your Lambda functions. So really, it's a platform that's it's an observability platform that's built for cloud developers by developers, and the Lumigo team, I know that they also use Lumigo to monitor Lumigo itself as well. And you also get the integration into your PagerDuty and other tools, so that you have alerting and all of that all in one package. And so I've been talking to Waldemar for a little while about LocalStack, something that I'm actually quite interested in learn more about, because honestly, I'm a bit of a skeptic when it comes to LocalStack. So I'm really hoping that Waldemar is going to change my mind tonight. So Waldemar, do you want to introduce LocalStack?
Absolutely, yeah. Thanks so much for that intro. Yeah, so with LocalStack, our mission kind of is to look into enabling cloud development and providing a seamless experience and solving some of the challenges that we're seeing with cloud development today. So if you just think about a typical life in the day of a cloud developer, right? So what you will soon experience is, let's assume you're developing some kind of a serverless application with AWS Cloud. There's typically quite a lot of different resources to manage, right? You have things like Lambda functions, you have some containers, databases, S3 buckets, and so on. So kind of lots of moving parts in general. And whenever you make a change, obviously, like the remote execution model of the cloud will typically require you to push an update to the cloud, just to get like these feedback cycles of changes, pushing to the cloud and then making some changes again. The other thing that we're seeing is, when it comes to remote debuggability, so assuming you have some kind of a CI/CD pipeline, and we're also going to show this a bit later today, assuming you have a red build in like one of your feature branches is maybe failing, it can be hard to figure out what was the root cause, kind of replicating the root cause on your local machine. Typically, you would do this with things like log output or metrics, or observability platforms like Lumigo, for example. But again, having some kind of a local execution environment can be beneficial there. And then also, what we see quite a bit is managing dev infrastructure is kind of a pain point slash creating a lot of overhead. So if you need to create one let's say sandbox environment per developer, it can easily kind of blow up your not only infrastructure budget, but also the management overhead of cleaning up all the resources and so on. So this is basically some of the challenges that we tried to address with our solution. And maybe if you can go to the next slide, please. So from a 10,000 feet view, LocalStack basically is this emulation platform, is this local cloud emulator, which allows you, if this blue box on this picture here is your application as it's moving through the different stages, right, from the local machine throughout some CI/CD process all the way to production. And the application is just talking to APIs, right? So API endpoints, and they just happen to be emulated on the local machine and in CI, and then sort of in the higher stages using the real cloud environment. The other thing, in addition to this core emulator, as we refer to it, we're increasingly focusing on value add features, for example, for team collaboration. So there's a feature that we call local cloud pods. It's basically a persistence mechanism. So you can take a persistent state of the container of your LocalStack instance and then easily share the state with your team members for collaboration purposes, for example. So if we have some time towards the end, I can also show briefly how this works. So this is kind of really from a 10,000 feet view. How we're addressing is, again, like the core part is really the emulator. And then the ecosystem of integrations. So that's kind of important to mention that there's lots of different tools. Thinking about things like Terraform or the CDK, just basically fitting into the existing workflow of a development team is really important for us. And I guess we're getting a lot of these integrations of the compatibility almost out of the box for free, quote unquote, because essentially you just need to point these tools to the local endpoints, and then they work pretty much out of the box for the most part. Right, kind of really rushing through the intro slides here. So I guess with that, unless you have any other thoughts at this point, Jan, we can dive a bit into some demos or any.
Yeah, sure. So I guess just to give everyone who's watching a little, I guess some signpost. So what we're going to do is we're going to do some demo of LocalStack, and then we're going to show you how the development and the test loop can work using LocalStack. And also we're going to show you how you can integrate LocalStack with Lumigo as well, so they can get that tracing and observability, not just for your application running in AWS, but also for when you're developing locally as well, so that all the way from local development to running in production, you can use Lumigo to help you monitor, debug and trace your more complex applications all the way through, so that you have one consistent tooling to help you debug and solve troubleshoot problems. And if you want to check out the demo that Waldemar is going to show you, you can also use the link here as well. The slides are going to be shared with everyone afterwards, so that you can always go check it out yourself. So with that, I'm going to hand it over to you, Waldemar. I'm going to have a few questions for you, maybe as we go. And maybe I guess while we're setting up, one of the things that I really agree with you earlier, that you said, local development is quite important practice, and some of the challenges in terms of the slow feedback loop. And that's where, I've been using practices like doing remote code testing, having your code running locally, but hitting real AWS services, and using temporary environments to kind of combat some of the same challenges that you talked about. But I guess with LocalStack, that's another way to approach it, using tools that can allow you to simulate AWS services locally. I have used LocalStack in the past, but this was quite a few years ago, and I've run into a number of challenges with using LocalStack around stability, but also in terms of missing, I guess, a feature gap, as well as not having support for IAM. So there are certain problems that you don't detect until much later. And from our conversation, I guess a couple of weeks ago, I think some of those you guys have been addressed this with LocalStack version 2. So I'm really curious to see how that works, including the IAM simulation and all of that as well. So I guess with that, I'm going to just hand it over to you and watch the demo.
Awesome. Yeah, very cool. Yeah, no, definitely. I think I can totally relate to what you're saying. Like if maybe some folks in the audience may have used LocalStack a couple of years ago, and today it's a completely different product. So definitely would give everybody the advice to give it another try. We actually have our version 3.0 release coming up next week. So if all goes well, then by end of next week you should have like heaps of new features and really cool features that the team is currently working on. So
Okay. So are we gonna see the 3.0 stuff today, or what we're seeing is 2.0?
So what we're seeing is basically still like a lot of what we're seeing is basically going into the 3.0 release as well. So we have basically like a you know, semantic versioning, but we're also, you know, releasing, we've done a bunch of features in the 2.30 release as well, but 3.0 is also an opportunity for us to introduce breaking changes, for example, in the configuration, and a lot of that can also be seen in the release notes on our Discuss and the GitHub.
Okay, that's good. Oh, by the way, if you guys have any questions, there's a Q&A widget at the bottom, so please put your questions there. We will keep an eye on it, but I think we probably just leave until the end to answer any questions you guys put in there.
Perfect. Awesome. Yeah, great. Yeah, so basically what we want to use for the demo here is a really simple application here. And again, this is available in the GitHub repo if you want to check it out maybe after the presentation. And so if you just you know, I've checked this out here in my IDE, and it's a really simple application. First of all, there's a make file with a couple of make targets just to install the application. And then it basically consists for the most part of a Lambda function that's just, you know, doing some simple processing. So this is a Node.js Lambda function that, you know, in general just uses a DynamoDB client to do a scan of some table. And then it's also basically sending a message to an SQS queue, right? So relatively simple logic here, but just to kind of showcase some of the functionalities in LocalStack. So one thing you will maybe notice here is so first of all we can create these clients, these AWS clients, just basically the same way as we would do with in a real you know, production system. So you can just create a DynamoDB client, do a scan on it with the table name. So in previous versions of LocalStack, you always had to essentially specify the endpoint URL for all the clients, but these days we're basically injecting that automatically into the environment, so you don't need to take care of that. And yeah, what we want to do is just, you know, run the simple Lambda and see and then iterate a bit on this application.
So on this Lambda function that you're going to be running, would it be running using the was it the Lampy container image that sort of kind of mirrors what's in the real Lambda function execution environment?
Yeah, so this is actually something that we used to use in the past. There's this lamp CI, which is basically a Docker image that provided this emulation. Nowadays, we're actually using the official AWS images. So we'll actually see this when we spin up the Lambda function. So we, in general, for the Lambda implementation, we're leveraging quite a bit of some of the open source tooling that AWS has put out there. So including the base images, which are super helpful for that purpose. Right, and the application itself is defined as a Terraform script here. So again, Terraform is one of the integrations that a lot of our users are using. So we have a Lumigo tracer token, which is basically read from the environment. I have to define in my terminal. We'll get to that in a second. Then we again define just a very simple DynamoDB table with just an ID attribute here. We define an SQS queue. And then some IAM roles and policies, and we'll actually get to that also in a bit more detail. So the Lambda itself has an execution role, right, which allows us to assume this role. And this is the actual definition of the Lambda function. So it's a Node.js, uses the Node.js 18 runtime. And you will note a few additions that we've added here. So first of all, we're introducing a layer that Lumigo provides as part of sort of the tracing functionality. And then the rest is just pointing to the zip file for the Lambda and just some timeout. And
right. So basically, the integration with Lumigo is through the Lambda layer, which is how the official Lumigo tracer is doing in the real AWS accounts, but you kind of just mirroring that in the local setup.
Yes, exactly. So when you do this setup in Lumigo directly, and I have this open here in my browser here. So when you set up your Lumigo integration, basically this will all happen under the covers for you. So Lumigo, you know, it basically instruments your AWS account, and you can you know this much better than me, obviously, Jan, but I think you can basically configure individual functions here and enable tracing here with this toggle. And then what happens that in the background, once you've given Lumigo access to your IAM account, it will actually, do the instrumentation and essentially add this layer to the function. And we're kind of, emulating or mirroring this in the local environment, but just adding this layer definition directly.
Right, gotcha.
Yeah. Yeah, right. So we'll get to the Lumigo part in a second. And then just this is, one more policy that we have defined further down here. And we'll actually, in the first iteration, we'll run LocalStack without IAM enforcement. So by default, when we deploy this application, it's a commit all system. So this is, by default, there is no IAM enforcement. That's why initially we can actually also just comment this out. And what I'm going to do now is just, go ahead to my terminal and just try and deploy this application. So let's go here. So I'll do just a fresh start of LocalStack here. So this is using the latest version, I believe, 2.3.0. And if I do a Docker PS here, basically I can see that the container has spun up here. And let me just do a clear here. So LocalStack is now already up and running. So what we can do here is we have this wrapper script called AWS
So just so I understand what's actually going on here, you earlier said the LocalStack start. How did you get to that point in the first place? So did you have to, because I guess you mentioned before you have some integration between LocalStack and Terraform. So is there like a step that Terraform prepare or build or something so that you package your function with the zip and all of that as well?
Yeah, 100%. So this is definitely yeah. So what I've done so far is only starting up LocalStack. So the application is not yet deployed.
Okay, gotcha.
In a second. So what I'm just going to do is use this AWS local command line, which allows us to do basic interactions. It's the same interface as the AWS CLI. So I can, for example, create a bucket here. And then it will list the bucket. So this is kind of the simplest integration you can have. And you can see here actually have debug tracing or debug logs enabled, so you can actually see the requests that are being made here against
okay. And this environment is persistent, so that if I create a bucket now, I stop LocalStack and start it again, the bucket is still going to be there.
So great question. So by default, it's actually ephemeral. So if I restart here, the state is flushed out. So you always get a fresh state.
Right.
We have a flag that you can set, which is persistence equals 1. If you set that on the startup, then basically the state will be persisted and reloaded on restart. But the default configuration, because that's what most users seem to prefer, is just to have a fresh environment for each start.
Gotcha.
Yeah. Cool. Right. And so now we have in this directory here, I have my main TF file and actually some helper make target. So let's take a quick look at the make file again. So we have this deploy target here, which basically does a couple of steps. So it first of all copies the Lambda handlers to /tmp, right? So copies them to temporary directory, creates a zip file with these lambdas, and then basically does a tf-local init and tf-local apply. So what is tf-local? Tf-local is the local equivalent of the Terraform CLI. So similar to what the AWS local is to AWS, we have this small wrapper script here. And basically what I'm going to do now is just run and deploy this script here. So I'm just going to do make deploy. And this is now basically, so literally Terraform has now already sort of come up with the plan, and it's starting to deploy all these resources that are defined in our Terraform script in itself. So we can see the function, the DynamoDB table, SQS. So I think for SQS, Terraform has some built-in checks, which are, I think, doing some polling if the queue attributes are already defined. So this should be done in a couple of seconds. And now it says apply complete, and the resources are now in the account or in the LocalStack instance. Maybe that's a good opportunity to quickly switch to our web application. So that's app.localstack.cloud, where among other things we have a small section that's called Resource Browser, and this will look maybe quite familiar to you. It's a very simplified, stripped down version of the AWS console. So we can now, for example, go to SQS here, and then we see the queue that was there deployed by Terraform, and we can also go to Lambda, for example, and take a look at this function. Later on, once we add some invocations, it would actually also print the logs and so on. So it's an additional way to interact with your local instances. And bear in mind, this browser is literally connecting to the local instance, so it's not calling out to the cloud. Nice, you have a guest there.
Yeah, like you got guess here.
Cool. All right. Yeah, so this is, basically the application is now deployed. So what we can do is we can now trigger some invocations, right? So there's actually another make target here, which is just called invoke. And this is just going to do AWS local lambda invoke using the function name and then just piping the output to a temporary file, right? So what we can do now is we can do make invoke, which calls the lambda function. And what happens now, and this is also to answer your question from before, which images we're using. You can see that this is actually using the public ECR registry from AWS with the lambda.js runtime, right? So that's the image we spin up here. AWS also has quite a neat tool called the Lambda runtime interface emulator. So that's basically the piece of code that sits inside this container and gets requests for invocations of lambdas, and this is basically how we interface from LocalStack to the Lambda container to trigger these invocations of lambdas.
Right. Okay.
Yeah. And so we can run these invocations here, and you can see it responds relatively quickly once the cold start in that sense has spun up the Lambda function. Okay, so this is kind of very simple. And by the way, what this is done now is basically put some messages to SQS. So we should actually be able to, if we do an SQS, I think I have this somewhere in my so if I do an SQS receive message from the queue URL, we get the message that the Lambda was actually writing to the queue, right? So if you remember from before, look again at the handler file, we have this piece of code here which sends a message with the message body hello from LocalStack, right?
Actually, looking at this code, this is using AWS SDK v3, but the npm package looks like it's v3, but then the methods, I thought they're all send. You have to construct a command object, so that the client looks like they're using v2's API, but they're coming from v3 package.
Yeah, that's actually a very good point. I was honestly pulling this together for just last night, and as far as I understand, they also have this compatibility mode where you can still use the previous version of V2, where you basically use the API operation directly.
Okay.
But you're right. I think that the new canonical way of doing it would be to create a request object and then sort of pass that down to the SDK. Yeah.
Okay. Didn't realize you can actually do that. Or I guess they're just not shipping the type definition for those methods, but they still have that under the hood.
Right.
That's funny.
Yeah.
Okay.
And I was a bit lazy and still sort of in the V2 land, so I just put it together.
No worries. So I saw you have the command AWS local. Is that something that you have to install separately, or is that something that just you're gonna get that when you install LocalStack?
Yeah, absolutely. So some of the tooling that we provide, and I think we have this also covered in our docs. So there's this AWS local, this T of local. So those are for the most part Python packages on PyPy. Actually, I have this also in my GitHub workflow definition here, which we also going to take a look at later. So you can basically do a pip install LocalStack, which installs the the CLI. Then we have Terraform local, and then we have this AWS CLI local, which is really the package for AWS local.
Okay, gotcha. Okay.
Yeah. And under the covers, you can either use version 1 or version 2 of the CLI. And in this case, I think I'm using the version 1.
Okay, gotcha.
I see that there's something popping up in the Q&A. I don't know if you want to take it now or
yeah. So there's a question here from Victor. Are Lambda cold starts simulated with LocalStack as well?
Yeah, that's a good question. So they are in a certain sense simulated or just effectively also happening, because maybe you noticed before that the first invocation of the Lambda was taking a bit more time because the container had to start up. We're basically copying the zip file into the container. So it's a bit of literal cold start happening also in LocalStack. And once the container is running, like the invocations are almost instantaneous.
Right. Okay.
Yeah.
So I guess it's not so much a simulation, but it's just well, when you implement the same behavior of loading a Lambda function and like a container worker, you're going to have those overhead. It's not so much that you're trying to simulate it, but just as part of implementing the Lambda behavior, you can end up with the same cold start.
Exactly. Yeah, 100%. So that's really, I guess, the nature of things, right? So yeah, it's very similar problem that we're also facing here, obviously.
Right. Okay. And another question from Victor is, with a large full-fledged AWS project with several services like API Gateway, Lambda, DynamoDB, OpenSearch, Message Broker, etc., how memory intensive is LocalStack with this scenario?
Yeah, it's a great point. So certainly, the local stack operates within the physical resource limits of your machine, right? So we have users with as little as 4 or 8 gigabytes of RAM. Typically, we recommend allocating 3 to 4 or more gigabytes to the Docker engine. So we definitely see, some larger scale use cases where users are using, dozens of Lambdas in a local environment, lots of SQS queues, for example, DynamoDB tables. Also, if the resources are idle, then they're not really consuming a lot of memory, right? So we also have the mechanism that, tears down containers if they're not being used for quite some time. And so we're trying to apply similar mechanisms and strategies as probably would do in a real infrastructure as well. So yeah, so there are obviously certain limits from the type of size of application you can run on the local machine, but we've seen that there are some fairly large use cases of users stretching the limits really of the local emulation as well.
Okay. And I guess similar to your integration with Terraform, do you also have integration with CDK and serverless framework as well?
Yeah, absolutely. So those are basically the 3 of the most used ones. So in our docs, there's actually a page on integrations. I believe it's here. If I can find user guides, integrations, and you'll find a bunch of different integrations.
Right,
Serverless is definitely quite a big one. Test containers, CDK, as you mentioned. So
as well. Okay.
CDK just maps to our CloudFormation and templates, and internally we have an implementation of CloudFormation.
Okay.
So there's quite a few different integrations here.
Okay, that's good. That's good.
Yeah. Okay, cool. So yeah, we're just trying to see in the flow what I wanted to show next. Yeah, so basically, now that this application is deployed locally, let's take a look at how the integration with Lumigo looks like, right? And if this deployment and if my key with my token tracer key is properly configured, we should now actually be able to see some live logs coming through. So let me go to Lumigo, and I'll go to this live tail tab here.
Mm-hmm.
And just observe what I'm doing. So I'm just going to run a couple of invokes, and what you can already see in the log output here is we actually see some Lumigo
Application logs. Yeah. Okay.
Yeah, some tracing information.
Yeah. Okay.
And if all goes well, yeah, we already see the traces coming in here. So again, I think this is pretty cool that you execute your Lambda function on the local machine, and we actually still get the traces and the visibility from Lumigo in there. We can actually go to one of these invocations here, and Lumigo shows us the graph of the resources. So in our case, it's relatively simple, right? It's just the function with the DynamoDB table and an SQS queue, but you can actually drill down all the way to the body of the request, the response
as well.
Yeah.
And I guess you can also look at the timeline. Can you look at the timeline as well? Does that work locally? So if you
Okay.
Yeah. So the timeline can show you, okay, that works as well. That's cool.
Yeah. So this is almost like if users are familiar with something like X-ray, for example, and this is really showing the detailed traces with the timeline. So really super useful.
And there's no need for manual instrumentation in this case. So just out of the box, I think oh yeah, the other thing that I was gonna ask about is the IAM, the permissions. You said by default IAM permissions is disabled. So how do you enable IAM permission if I want to check? Because one of the things that I want to be able to simulate while I'm running my code locally is detect any IAM permission problems.
100%. Yeah, absolutely. So we'll look into the IAM in a second. I just wanted to briefly show, because we already have this running, one other aspect is what we call hot reloading. So hot reloading basically is a mechanism to change the configuration of your Lambda to be able to make changes in the handler file and immediately see the changes reflected in the next invocation. So I have this make target here, which is called hot reload. So I can, and what this basically does is it updates the function codes to point to a predefined bucket that's just called hot reload. That's, you know, a special sort of bucket name in LocalStack. And then you specify as the S3 key your local directory on the host and the, you know, where the Lambda handler files are basically located. So I'll just run this real quick here. So what we do is we do make hot reload. So now this hot reloading is enabled for this Lambda function. And what I can do now is I can make changes directly to the handler. So we can, I don't know, for example, we can throw an error here and see what happens. And notice without redeploying, I'm just going to do another invoke here. And we should get the error invocation from what we just did, right? So we're getting an unhandled. Actually, we do a cat tmp out. We actually see the error here coming through. I could also make some other changes. I could say, let's return a different message here. Hello, Lumigo, right? Just saving it, running the invocation again. And then I can see, now it should be successful. And I can see the output here. So, and the way we do this is we essentially just, you know, take the user's code on the host and just mount it into the container, right? So on the next invocation, it's always immediately reflected, basically.
Okay. I guess that this is fine when you have one function, but most projects going to have more than a dozen functions. How easily can you scale that to, projects with say, I don't know, 15, 20 Lambda functions because you've got API gateway, you got one route per function?
Yeah, so that's a good point. That piece actually, so the hot reload actually scales reasonably well because it's mostly a matter of so what actually happens under the covers is that we've stopped the container before. So when we do the update function code call, we're stopping the container, we restarted with the mounted code, and then from then on it's just serving the local files. So that's actually relatively quick. We have another mechanism for debugging where you can set actual breakpoints in your Lambda function. I don't have this deployed right now, but we can do this in a follow-up maybe, where basically we need a debug port for each Lambda function. And this actually scales a bit less well for several functions. So if you want to do actual breakpointing and debug points, that's a bit more tricky. But the hot reload is actually something that scales really easily to various numbers of functions. So that's quite scalable. Yeah, so that's one of the things that, I guess our users are quite excited about this really quick iterations. And if, I guess all goes well, we should still see the invocations coming through here because that's been, still the same setup as before. Actually, let's do another quick invoke. This is still coming through. I think there's a bit of a delay for a couple of seconds, and then they should see them coming here. Yeah, coming through.
They're coming through now.
Cool. Okay. Yeah, so now switch gears a bit and really directly answering your question for IAM, right? So this is actually the next piece that I wanted to cover here in the flow. So yeah, we looked at the hot reloading. So this is also in the slides if anyone wants to take a look afterwards. Now, let's add some IAM because as you mentioned, Jan, it's one of the main pain points for cloud development, especially when you come from a local environment and then sort of transitioning into the real cloud. That's why we've invested quite some time and effort for an IAM enforcement engine that is sitting inside LocalStack. It needs to be explicitly enabled with a config flag. It's called enforce IAM =1. And then you will actually see things like an access denied exception if a certain permission is not granted in your setup, right? So what I'm going to do is I'm going to go here, restart LocalStack, and this time with enforce IAM equals 1. So now basically we have the mechanism to, like, any request is now being observed, whether we have a valid policy. And what I'm going to do here, I'll start adding some permissions, but not all of the required permissions, right? So I'll just add basically the permissions for creating log stream log groups. That's essentially required even for the Lambda to deploy properly and send logs to CloudWatch. But I'll leave out the DynamoDB scan and SQS send message for now, right? So I'm just going to do a quick deploy here. Again, now we're deploying this configuration with IAM enforcement enabled. So and the default user that we use is root. So the Terraform script here is using a root user, which has all the permissions, but the Lambda function itself executes under an execution role, which only has certain privileges, right? And needs the proper permissions for that. So let's just quickly wait until it's deployed. And now, okay, it's of course, now we're actually already seeing the pass roll, okay. So, oh yeah, okay, I see. So there's one thing actually for this demo, we need to do a small change here and comment out the layer, because that's actually something where now actually the IAM enforcement is kicking in and saying, okay, you cannot, there's no cross account policy basically defined for that. So we'll just deploy this again. I've just commented out this layer code in the Lambda. So now it's deploying again, and now we should be able to see the function in a couple of seconds. And now basically what we're expecting to happen, if we look again at the handler code, we're trying to do a DynamoDB scan and an SQS send message. And both of these permissions are not yet granted to the IAM to the Lambda execution role. So we would be expecting to see an error on the invocation here. Right, okay, cool. So it's deployed. So I'll do another invoke. And now let's see. Yeah, so we get an unhandled error. And if you scroll up here, you can actually see DynamoDB scan is not, is missing for this particular IAM execution role. So it actually, the other cool thing that you see here, it's what we call explainable IAM, because it really tells you exactly what is currently missing in your setup that sort of denies this request, right? Mm-hmm. So we can now go back. So right now we're missing the DynamoDB scan. So let's just add that into our main TF file. Mm-hmm. So this is really how you can see we can now iterate really on this scenario. So let me just add this.
So can we go back to that again? Because you essentially got star there, but in the real project, I would never do that. I will have a get attribute to get the DynamoDB resource instead. And I noticed that in your ARN, you're using fake fake account ID. So does that still work when you've got what you was exactly that's.
Great point. I haven't tested it, but it should work. So let's just give it a try. Live demo. That's what we're all here for. What could possibly go wrong? So let me just, before we apply this, let me just run this one more time here to see. So this should now have enabled the DynamoDB scan, but it should still block the SQS send. So if we do another invocation, we should see another error now for SQS. Yep, SQS access denied.
Okay. And
now let's try actually with what you were mentioning before. So let's also comment that in and say we want to have our SQS queue test and then the, I guess, the ARN. Okay, let's see. Do another TF local apply. So now it's doing only the incremental change, right? So Terraform now sees that there's only one change that needs to be applied. And now the moment of truth, if this actually works with, yeah, cool.
That worked. Okay.
Went through with 200. Again, like this is fairly cool, and as you really pointed out here correctly, so we can still leverage the power of these infrastructures, code tools like referencing the ARNs and so on, and in fact, this actually will be a great segue to also making that change directly in the repository, because I agree with you that this is much better than having the wildcards, which is not really a very secure thing. So this is kind of the IAM enforcement. Let me just quickly see if there's any questions in the chat here.
There's a question from Victor. How does LocalStack manage to stay updated with the latest changes, essentially in the AWS services? And what's the typical delay before, say, reInvent just around the corner? They're going to announce a bunch of things. What's the typical sort of time frame it takes you guys to get up to date with the latest features?
Absolutely, great question. In fact, we do even have a backup slide, because I was actually anticipating this particular question. Maybe we can actually come back to that towards the end, but it's a great question. Let's please definitely come back to that question. The only brief thing I wanted to show before we go into the further Q&A is looking into CI/CD pipelines, right? So we've now done a bunch of tests locally. And one of the powers of LocalStack is also it's very easy to have a repeatable environment also in a CI build, right? So what we're going to do is basically take I've created a GitHub action workflow here, which basically just checks out the code, sets up Python, installs LocalStack, and it just runs a couple of tests, basically the same things that we've been running locally, just make deploy, make invoke, and then check if we can receive the message, right? And I'm actually going to do this change now that you pointed out, Yan, with the wildcard IAM. So let's just call that something like branch no IAM wildcard. Check this out. And we're just going to commit this piece of code here. And this is just in a README. We can push that. This is just the change in the Lambda. We've commented out the layer, which is also fine. And this is the change. Okay, so we're going to say remove or replace IAM wildcards with ARNs, right? Okay, so this is the typical flow that you would do for a PR build. So we're pushing this to a branch, and I'm heading over to my repository here, and we can already see that this branch has been pushed, and I'm creating a pull request here. And what's happening directly after I create the PR, it just triggers the build, right? And we can now see that basically the script is executing. It's installing LocalStack. It's running the test. This is going to take approximately 1 to 2 minutes until this is kind of finalized. But you can see it's now pulling the image, starting it up, and running the test. And we can come back to that in a second and see if that has succeeded. But I guess what I'm trying to show here is that it's very easy to replicate the local setup to your CI pipelines and really have this confidence that your changes are really working. So it's also, and here we're not only testing the application logic, but also the infrastructure deployment, right? We're really, creating the DynamoDB table, the Lambda function, and all that. And this is we believe one of the beauties of having these frequent testing, just from the very get-go, integrating it into your CI pipelines and making sure that everything is properly tested. So we'll come back to that and see if the test is then succeeded in a couple of minutes. And yeah, so I guess this kind of already brings us to some of the conclusions, and we also get to the question that was asked from the audience. But maybe just to some of the takeaways that we've come up here with in this short webinar. So first of all, we really want to cherish the inner dev loop, right? So having these quick cycles of iteration where you can do things like the hot reload and even setting breakpoints in your Lambda code, which we haven't shown today, but we can also do this with LocalStack. So that is really critical for quick iterations for your development. Observability, we've seen this with Lumigo. I think it's really worthwhile putting that in from the very get-go in the process, right? Because it'll be very helpful once issues arise in production or even development to have this observability, see all the traces in the logs. And again, I think Lumigo has been a great example here to show how easy it is to expose this in a UI. And then, the third point is repeatability and testing is a bit of an upfront investment, right? But it pays off in the longer term. So, it will maybe require you a bit of time to, set up something like LocalStack, for example, or also the CI builds. But it's a great investment that increases the quality of your application. This is also the point number 4 here, that testing not only the application code, but also the infrastructure code, and doing this frequently is really one of the essential points to improve quality of the applications and make sure that things are working properly. And then number 5, that's also an important point to make here, is that what we've shown here is not a replacement for staging, right? So ideally you would still have a some smoke tests or something that actually executes in the real environment before hitting production. It's more really a pre-staging tooling that helps you iterate quickly. But again, I don't think we're arguing for a replacement here of a staging environment, for example. So maybe anything to add from your perspective, Yan? You also have a lot of experience in the testing space as well.
Yeah, so I guess that, this is very, in terms of the goal, it's very similar to what I've been doing, but I've been using practices instead of tools. So, I've been using practices like remote testing and using ephemeral environments to achieve the same results, but instead of simulating the AWS services locally, I'm talking to the real temporary like SQS queues and things like that locally from local code running locally, talking to the real AWS services by using temporary environments. So I guess the difference here is that by running going with LocalStack, potentially things are a little bit faster. I guess that compared to if I was to have to deploy my stack against the real AWS services, and I guess especially in the CI, provisioning a new stack in the LocalStack would be quicker than compared to provisioning the real environment in the AWS, even if it's a temporary environment.
Absolutely, yeah, 100%. So, and again, I think there's probably no silver bullet to solve, the right answer for all use cases. So I think there are certainly cases where you might want to, use the real environment for testing, especially if it's a large integration and maybe you have lots of dependencies to other services that you're already using. I agree with you on the point that the sort of agility and speed can definitely be a factor, especially if you do quick or like a frequent testing and frequent creation and deletion of resources. So we've seen some resources like RDS databases, for example, that can take relatively long time to spin up in the real environment, and in a local setting, it's obviously much faster. So we're talking, 10 minutes or more in AWS versus a couple of seconds locally. So I think there's a few cases where it's extremely beneficial, but I also agree with the point that maybe you want to just run your code logic locally and then connect to the remote resources. That can also make a lot of sense in a lot of use cases.
Yeah, I think the RDS one is really interesting because it's the RDS and other stateful services not only create not only is it slower to deploy, but also it forces you to, when you're using temporary environments, it also forces you to have special handling for those temporary environments, because you don't want to run 50 different RDS instances, because you want to have one instance for every environment. So for that, you typically have to share the RDS cluster, but then have environment-specific tables, which means additional scripting and automation you have to do. Whereas with LocalStack, that becomes a much easier, becomes a non-problem, because it's just tied to that ephemeral environment. Okay, that's a really interesting angle, which I think for those cases I can definitely see LocalStack being a lot easier to use than what I've been doing. Okay. Oh, so there's the question about the Victor had about the feature parity and the lead time to catching up.
Perfect. Yeah, great segue into that question. So So in fact, so this parity, it's API parity is one of the things that's really very critical for us, right? So we spend a lot of time and effort into making sure that the implementations are on par with the real service. So there is actually a nice blog post that I can definitely recommend if you want to check it out here, where we're explaining some of the mechanisms that we've developed to ensure that we have the highest parity possible. So that ranges from automatic scraping of the APIs that AWS provides, the specifications, and then doing some code generation on our end, for example. But also a mechanism called snapshot testing, where basically we run a lot of tests against AWS first, record all the responses, and then run them against LocalStack and make sure that there's no discrepancies, right? So, and again, this is explained in much more detail here in this blog post, which I can definitely recommend taking a look at. And also, if you're interested, there is a fairly detailed coverage page per service. So we also try to be very transparent when it comes to just showcasing what is available and what's not. So, on this page here, you can, for example, let's go to SQS, and you get a fairly detailed sort of insight into which methods are implemented, whether and how much they are covered by tests, by AWS validated tests here, for example, snapshot tests. And then also the ones that are grayed out are the operations that are currently not yet supported, right? So it's fairly, so we try to be fairly transparent and just make this publicly available, what's supported and what not. So so users can get like a detailed insight into that here.
Okay, so if I guess I'm interested in this particular area. I'm interested in knowing when I've hit something that is not supported, so that because obviously if I'm getting used to using LocalStack, I'm going to be using it for everything. I'm not going to be manually checking every single thing that my function is doing, or maybe even I'm using libraries that are calling AWS services and doing things I'm not even aware of. So how do I know when I've hit an API that's not supported? And that's why I'm seeing like an error in my local stack.
Yeah, right. That's a great point. So in fact, what you would see is basically a 501 not implemented error. So this is literally what we return. And the good thing is we have some insights into and some visibility into these 501 errors. So essentially we just, there's some anonymized, reporting, and we can then figure out, okay, this is an often requested API endpoint that we should implement.
Right.
So this is basically how we can also prioritize some of the efforts internally as well.
Okay. And so speaking about like some of this reporting, Victor asked, it looks like you can develop locally with LocalStack without internet connection. Is that correct?
Yeah, that's a great point. And in fact, I think one of our taglines is develop your cloud and serverless applications offline. There is a bit of a caveat to that. So first of all, when the container starts up, especially also our pro version, there is a short connectivity where we check the API key that's configured in the instance, and that requires connectivity. And the other point is that we tend to keep the base image small, the Docker image, and then in some cases, for some services, there is some lazy installation of dependencies at runtime. So, for example, if you're spinning up an Athena SQL query or something, then there is some additional dependencies that need to be installed. But typically, once the system is kind of bootstrapped in that sense, the container is up and running, you can literally develop offline. And in fact, we've had cases where we were, creating some sample apps on the plane, and so it really is possible. Yeah.
Wait. But then that means you have to have it running first before you close the laptop, go to the airport, and jump on a plane.
Yeah, so yeah, exactly. So ideally, in that case, you would have to create, run the container and then close the laptop, open it up again.
And go, okay, right. So it's not really a case of okay, now I'm on a plane. Okay, let me do some work, and then I have to start a container. But at that point, it's going to check my API key, and it's going to fail. And
yeah, exactly.
okay.
So I would say it's offline with an asterisk and like a small print, almost offline.
Yeah, I mean, and also I guess the offline is not that big a deal. I mean, everybody is always in the Wi-Fi connected locations most of the time anyway.
Yeah, 100%.
So it's probably not that big a deal. And I know it's like a thing you can do, but I'm connected to that 24/7. So okay. Okay, so I think that's all the questions I've got. Does anyone else have any questions for Waldemar? And before we wrap things up?
Maybe while there's some questions coming in, so I'm going to just take a look at our CI build. So this is
Okay.
completed.
Oh, yeah.
In the meantime, so we've run the test. You can just see the Terraform output here, and it applies the changes. And then I think towards the end we have an invocation of the Lambda function, and we also receive the SQS message, and then just grab for this content.
How long did that deployment took?
So the overall end-to-end run was 1 minute 54 in this case.
Okay.
So the end-to-end run a bit less than 2 minutes. So typically, yeah, pulling the image, starting up LocalStack typically takes maybe half a minute or so. Then Terraform maybe another half a minute or minute, and then just the test itself. So I think that's the overall time essentially.
Okay. So I don't think that's actually okay. Maybe that is probably half the time you would take, but I guess this is just one function project.
Yeah.
Okay.
Yeah, exactly.
But I guess it's probably fair to say that the cloud LocalStack is going to be at least 40-50% faster to deploy, and especially if you're doing locally, then with the hot reload, you probably don't need to be running deployment constantly.
Yeah, absolutely, 100%. And as you mentioned before, the advantage is you have this throwaway environment essentially where no resource conflicts are happening. And maybe I just wanted to give one outlook, because you mentioned ephemeral environments before. It's something that we're still, I would say, pondering over, but we actually started creating a bit of a first POC for literally creating also ephemeral instances. So you can actually spin up a small sort of hosted version of a LocalStack container that is then accessible remotely for a couple of hours or so, which can then be used to, for example, create previews of a PR build. So let's assume you have something like a front-end application that has a UI, and you make it a PR build. You can then host this and share it with your team members and say, okay, do you like this change? And you can literally host it in a small ephemeral sandbox. So that's something we're currently, it's still in the alpha stage, but we're quite excited about this feature as well.
Right. So this is basically your cloud-hosted instance of your LocalStack environment.
Yes. Yeah. Exactly.
Okay.
Yeah.
Okay, that's interesting.
So, but again, it's still like more coming soon for sure.
And I think you mentioned earlier, or maybe just kind of briefly went through those different editions. There's the community and the pro edition. What's the difference?
Yeah, so definitely. So in community, that's essentially everything that's in our public GitHub. So the open source version, where we have a lot of the the core platform, some of the key services are provided there. And that's basically our community version. It's open source. You can also contribute to it. We're very happy to accept contributions. And then we also have our sort of commercial tiers, which pro, a team, and an enterprise version, where we just provide a lot of additional services. So you get things like, I don't know, a Cognito, a CloudFront, a Athena, a Glue, like some more advanced services. Right. And then also some of the collaboration features, like, for example, Cloud Pods. I'm afraid we're running out of time, so I can't show this anymore, but some really cool features as well to handle state and do team collaboration. And a lot of the features that we also saw in the dashboard here in the web UI are also part of the pro offerings.
Okay, so I guess if you want to have just basic things like API Gateway, Lambda, DynamoDB, those are all community edition is covered. But then if you want to have other services like Athena and things like that, then you need to have the pro or team edition.
Yeah, exactly.
Okay,
yeah.
Okay, gotcha. And I guess on top of that, you also need to have the right licensing for Docker, because everything's running on Docker. So you have to have if you're like an enterprise, you have to pay for Docker as well, I guess. Yeah,
it's interesting. Docker is, we strongly build on Docker. We also have an integration with Podman, so you can also run it, in a Podman environment locally, which is less restricted from a commercial point of view. We also have a couple of users and customers using Kubernetes as a deployment environment, right? If it's maybe on a shared instance or a cluster or something. But yeah, Docker has been an interesting journey. So let's see how that plays out over the next couple of months and years. Yeah.
Okay, great. So thank you so much, Waldemar, and thanks everyone for joining us tonight. And I guess the slides and the recording is going to be available. It's going to send to you by email in a couple of days. And so yeah, with that, thank you everyone, and I guess now wish you guys have a good evening. And thank you again, Waldemar, and see you next time. Have a good evening.
Thank you so much. It's great. Thanks for having me.